All right, hi folks, this is Larry Maslino. I'm recording a video for MATH022, and I wanted to do a few examples from Objective 13. Objective 13 is going to mostly involve multiplying out polynomials. So I'll explain what a polynomial is, and let's do a bunch of examples. First, let's go to this initial one. It says evaluating a quadratic expression. Now, when they say quadratic expression, what that means is the expression has a squared term in it. So the expression has, let's say, an x squared in it. In this example, they're using the letter C. So for this example, the expression has a c squared in it. That's what they mean when they say quadratic. Well, here's the question. Evaluate this expression when c equals 4. Well, all that really is asking you to do is substitute the number 4 in place of the letter C and then work this out. I'll have to follow order of operations. So I'm going to do that. All right. So I'm going to replace this letter C with a 4. That's going to be 4 squared plus 6 times 4 plus 8. So anywhere I saw C, I replace it with the number 4. Now I've got to follow order of operations. Order of operations says you should always do exponents first. So I'm going to work out 4 to the exponent 2, that's 16. Order of operations is next do multiplications. So I'm going to work out the multiplication. 6 times 4 is 24. Let me write this over here. Now I have additions. Well, order of operations says now go from left to right. All right, well, 16 plus 24 is 40. And finally, 40 plus 8 is 48. So evaluating an expression really just means replace the letter, we call it the variable, replace the variable with the number that is given to you, and then just follow order of operations to come up with a final numeric answer. All right, let's go to using this distributive property. All right. Well, in this example, they're asking us to combine like terms. All right. Remember, like terms means you have the same variable with the same exponent on it. So if I'm adding 3x plus 5x, the variable part is exactly the same. You add the numbers together and keep the variable. If I had 4y squared plus 7y squared, you keep the variable part the same, y squared, and you add the numbers together. 4 plus 7 is 11. Remember, I can't add 3x plus 9y together. Cannot add these. These are not like terms. All right, well, let's take this example. Now, what they're giving me is a subtraction in front of a parenthesis. When I have a subtraction sign like this in front of a parenthesis, you can almost think of it as distributing the subtraction sign inside the parenthesis. What that does is it changes the sign of every expression inside the parenthesis. So if you look at this 2y, it's starting out as negative. But because of this subtraction in front of the parenthesis, I have to change the sign. That's going to flip it to be positive. Let me look at this plus 3x. It's positive inside the parenthesis, but because there's the negative sign in front of the parenthesis, I have to change the plus 3x to be a minus 3x. And I'm just going to copy the minus y down. Now I'm going to combine like terms. I have an x subtract 3x. Those are like terms. If I combine those together, I get negative 2x. And then I have plus 2y subtract 1y. Well, those are like terms. When I combine those together, I just get plus 1y, or we'll just write as y. Now I have to stop because now I have unlike terms. That's how I know this is the final answer. I can't simplify it anymore. So the final answer here is negative 2x plus y. All right, let's do a few more examples. Let's go to an example using the product rule. So you might remember a rule for exponents, which is on the reference packet. It shows like this. It says b to the m times b to the n is b to the m plus n. So what this says is when you're multiplying the same bases together, in this case, the base is b, keep the base the same, but add the exponents together. All right, well, here's the expression they're giving us. Well, you might remember one way to get started here is reorder the multiplication if you want to. Because anytime you have a multiplication, you're free to rearrange the multiplication in any order you want. Well, I'm going to rearrange this to make it a little easier by putting the numbers in front. So it's a 4, a 3, and a 4. I'll kind of group those together. Then I'm going to write the W's. There's a W to the 3 and a W to the 9. And now I'm going to write the V's. There's a V, which I'll write as V to the 1 and a V to the 8. All right, well, now I'm just going to simplify this. First, I'm going to multiply these numbers together. 4 times 3 is 12. 12 times 4 is 48. Now I have W to the 3 times W to the 9. But this is where this product rule comes in. It says keep the variable the same W, but add the exponents. Well, 3 plus 9 is 12. I'm going to do the same thing for V. Keep the base the same, which is V, and these exponents together. 1 plus 8 is 9. Now I have to stop. I can't simplify this anymore because now notice these are different bases. I have a W and a V. I can't use this product rule. The only time I can use the product rule is when the bases are the same. That's how I know this is the final answer. I have to stop here. All right, so this is using the product rule, which is on that reference packet. All right, why don't we do an example of combining like terms? Now, again, in this example, you'll notice there's a subtraction here in front of this second parenthesis. So I'm going to write the first parenthesis down here. Now, remember, when you have a parenthesis, when you have a subtraction in front of a parenthesis, you can remove the parenthesis by changing the sign of each term in the back parenthesis. So this 7xy squared is starting out as positive, but because of that subtraction sign in front of the parenthesis, it flips it to be minus. Let me come back here. I'm going to think of this 5xy as negative, but because there's a subtraction in front, it's going to flip the 5xy to be a positive. All right, now I'm going to try to combine like terms. Now remember, to combine like terms, you have to have the exact same letter part. Well, let me look here. This is in this first term, there's an x squared and a y. There's no other matches. This is x and a y squared, but that doesn't match. So there's no other like term, so I'm just going to copy this down. All right, then I have a plus 3. Well, there's no other numbers to match that up with, so I'm just going to copy that down. Now I have a minus 1xy. Well, that does match up with 5xy because the letter parts are the same. So I can combine that. I have bring the xy down and add the numbers in front. Well, negative 1 plus 5 is a positive. And then the negative 7xy squared is alone with no other like terms. So this is the final answer. I can't do anything else to combine these terms together, so I just leave it as is. All right, let's come down here to multiplying. So here's what they're asking me to do on this one. They're asking, by the way, folks, remember you have this explanation for each one of these topics. So if you click the explanation, notice it's going to show you step by step how to work through this problem. All right, so let's do this. Well, one thing I could do here is if I wanted to, this is up to you, but I could take this 4b to the 5th and put it in front of the parentheses. That makes it just a little easier to recognize this as the distributive property. So I'm allowed to do that because this is really a multiplication. The parenthesis is multiplying 4b to the 5th. But remember, you can always swap around the order of a multiplication, which is what I just did. Now, this is the distributive property. What that means is take this expression in front and let it multiply each one of these three expressions inside the parentheses. All right, I'm going to write this out. So 4b to the 5 is going to multiply 7b to the 4. Then I'm going to bring the subtraction sign down with me. 4b to the 5 is now going to multiply 10b to the 3rd. And I'm going to bring this plus sign down with me. And finally, 4b to the 5th is going to multiply 7. Well, now I'm just going to simplify each one of these expressions. 4 times 7 is 28. B to the 5 multiplying b to the 4, that's the product rule. Add the exponents together, that's b to the 9. All right, let me come here. 4 times 10 is 40. Now I have b to the 5th multiplying b to the 3rd. Add the exponents, that's b to the 8. Finally, back here, 4 times 7 is 28. Bring down the b to the 5. I have to stop here because there are no like terms. Remember, for like terms, you would have to have the exact same letter part. Well, this is b to the 9. That's different than b to the 8. That's different than b to the 5. So there's no like terms here. So I cannot do anything else to simplify. So that's going to be the final answer on this one. All right. Well, let's go to multiplying what are called binomials. All right, so let me write this out here. Now, what we want to do is multiply one parenthesis times another. Now, to do this, there's a certain rule that you have to follow. What you do is you take each expression in the first parenthesis and multiply times each expression in the second parenthesis. Then in the end, we'll try to combine like terms if possible. Let me show you what this means. I'm going to start here with this x. I'm going to let this multiply each expression in the back parenthesis. So first, x is going to multiply x. I'm going to write this out. So it's going to be x is going to multiply x. Then x is going to multiply this 3. I'll write that as 3x. Now, let me come back here. I'm going to think of this as a negative 6. So this negative 6 is going to multiply x, and this negative 6 is going to multiply 3. All right, now let me go ahead and clean this up. Well, here, x times x, this is really the product rule because this is x to the 1 times x to the 1. Keep the base the same, x, but add the exponents. 1 plus 1 is 2. So you're going to be doing this a lot. X times x is really the same as x to the 1 times x to the 1, which is going to be x to the 2. All right, let me come here. In this middle, I have like terms. This is plus 3x subtract 6x. Well, for that, that's going to end up being 8 minus 3x. And finally, in the back, 6 times 3 is 18. And I have to stop here because now these are all unlike terms, so I can't do any more simplifying. Now, sometimes you'll see this mentioned as a FOIL kind of multiplication. The reason it's mentioned as a FOIL multiplication because you're multiplying the first term in each parenthesis. Here's the first term times the first term. Then you're multiplying the outside terms. That's the x and the 3. Those are like the outer terms. Then you're multiplying the inside terms. The inside terms would be this negative 6 and x. And finally, you're multiplying the last terms in each parenthesis, the 6 and the 3. But I think this way is a little easier to think about it because you're really just taking each expression in the first parenthesis and multiplying times each expression in the second parenthesis. All right, let's do another example like this. How about if we do this? Let's do this example here. All right. Well, this is going to be the same method. Let me write this out. 2 plus 3x times 5 minus 6x. The rule is take each expression in the first parenthesis and let it multiply each expression in the back parenthesis. So I'm going to start with this 2. This 2 is going to multiply the 5. So I'm just going to write it all out to make it clear what we're doing here. So the 2 multiplies the 5. Then the 2 multiplies this 6x. Negative, I'm going to think of this as a negative 6x back here. All right, now let me move to the second expression, which is this 3x. All right, the 3x is going to multiply the 5. And finally, this 3x is going to multiply the negative 6x in the back. And once you do all these multiplications, you add these results together as I'm doing here. All right, let me simplify each one of these expressions. 2 times 5 is 10. 2 times negative 6x here is negative 12x. 3x times 5 is 15x. And in the back here, I have a 3 times negative 6, which is negative 18. But I also have an x times x. Remember, that's really x to the 1 times x to the 1. Product rule says add the exponents, so that's x to the 2. Last step, I'm noticing there's like terms here in the middle, so I can add those together. So negative 12x and 15x, keep the x, add the numbers in front together. Negative 12 plus 15 is a positive 3. So here is the final answer. Now, one comment is anytime you add a negative quantity like this, it's the same as subtracting. So another way you could write this answer is like this with a subtraction sign. This would be okay also. Either one of these answers is acceptable. Notice I have to stop here because these are unlike terms, so I can't do anything else to combine these together. All right, let's do a few more examples. How about if we do an example here where there's more than one variable involved. So notice here there's both an x and a y. Well, that doesn't really matter for this multiplication. We just follow the exact same steps. So I'm going to start here in front, and I'm going to let this 3x multiply this 3x. Again, I'm going to write this all out. Then the 3x multiplies this negative 7y. All right, let me come to this back expression. I'm going to think of this as a negative 4y. The negative 4y is going to multiply 3x, and then the negative 4y is going to multiply negative 7y. Now I'm going to simplify each one of these expressions. 3x times 3x, well, 3 times 3 is 9, and x to the 1 times x to the 1 is x to the 2. All right, here 3 times negative 7 is negative 21, and there's an x and a y there. All right, this is going to be minus 4 times 3 is 12, and there's an x and a y here. Now in the back here, this is a negative 4 times a negative 7, but a negative times a negative is a positive, so that's going to be 28. Then I have a y to the 1 times y to the 1. Product rule says make that y to the 2. Well, there's one more step because I'm noticing these middle terms are like terms. So I have a negative 21 subtract 12. Well, a negative 21 subtract 12 is going to be a negative 33, I think. Yeah, negative 33xy plus 28y squared. This is the final answer because I can't combine like terms. Remember, if you're adding a negative quantity, that's the same as subtracting. So I can also write this using a subtraction sign if I want. Either one of these answers are equally correct. All right, so again, this is a multiplication. The reason they call it a binomial is this first parenthesis has 2 terms to it. So when you have 2 terms like that, they call it a binomial. All right, let's do a few more examples. Here is another example using multiplying what's called a conjugate. So what they mean when they use the word conjugate is notice these parentheses look the same, except one has a plus sign and one has a minus sign. Those 2 expressions are called conjugates. It's the exact same expression. The only difference is one has a plus sign, one has a minus sign. Well, I'm just going to multiply this just like we did the previous examples. Let me start in the first parenthesis. I'm going to take this y and let it multiply that y to begin with. That's y times y. Then I'm going to let this y multiply this negative 10 in the back. So that's going to be minus 10y. Now I'm going to move here to this 10. That 10 multiplies the y in the back. That's plus 10y. And finally, this 10 multiplies the negative 10 in the back like that. All right, let me clean this up. Well, this is y to the 1 times y to the 1, which is y squared. Notice something strange happens here in the middle. When I go to combine these like terms in the middle, I have a negative 10y plus 10y. Well, those cancel out. Right? Really, those add together get me 0. So I could write 0 there, but we're not going to write 0 because usually you leave that out. In the back here, 10 times negative 10 is negative 100. So I could just write this as y squared plus negative 100. Remember, anytime you add a negative, you can write it as a subtraction. So I could write it as y squared minus 100. Either one of these answers are okay. So when you multiply these conjugate binomials like this, you're always going to see that the middle terms cancel out. All right, let's go ahead and do a couple more examples. Here is squaring a binomial. All right, well, on this one, what they're giving me is a parenthesis to the exponent 2. Well, really the base here is this parenthesis 4w plus 3. And that base is being raised to the exponent 2. Well, you know what an exponent 2 means. You know, if I had 5 to the 2 means take the base times itself 2 times. Well, I'm going to do that. I'm going to take the base times itself 2 times. That really means take 4w plus 3 and multiply it times itself 2 times. But now this is going to be a multiplication like we've been talking about. Let me start with this 4w in front. I'm going to let it multiply this 4w in the back. Then this 4w is going to multiply the 3 in the back. All right, let me come over here to this 3. I'm going to let it multiply the 4w there. And finally, the 3 in front multiplies the 3 in the back. Now I'm just going to simplify each one of these. 4w times 4w. 4 times 4 is 16. And I have w to the 1 times w to the 1. Product rule says I should add the exponent, so that's w to the 2. Here I have 4 times 3, that's 12, so that's a 12w. Here I have 3 times 4, that's also 12, so that's another 12w. And the back here, 3 times 3 is 9. Last step, I can combine these middle terms. I have 12w plus 12w, well, that combines for 24w. So that's the final answer. I can't do anything else to simplify this final answer because these are all unlike terms. So this is the final answer. So the key to this problem was noticing when you have a parenthesis like this with an addition in to the exponent 2, rewrite it as one parenthesis, as the parenthesis times itself. Then you can follow the same steps for multiplying out 2 parentheses like this. All right, let me do one more example here. All right, now this gets a little more complicated because you'll notice that in the first parenthesis, there's 3 terms, and in the second parenthesis, there's 3 terms. So this is going to be messy, but let's set it up. All right, I'm going to follow the exact same rule, though, because I have one parenthesis multiplying a second parenthesis. So the rule is start with each term in the first parenthesis and let it multiply each term in the second parenthesis. All right, so I'm going to start writing this out. This is going to be a little messy, but I'm going to do it. All right, 2u squared multiplies the u squared in back. Now this 2u squared is going to multiply this negative 6u in the back. And finally, this 2u squared is going to multiply the negative 1. All right, let me keep going. Now I'm going to go here. I'm going to think this is negative 5u. And negative 5u is going to multiply each of these expressions. So this is going to be negative 5u multiplying u squared, negative 5u multiplying negative 6u, and then negative 5u multiplying negative 1. All right, one more multiplication. I'm going to take this negative 7 and let it multiply the u squared. The negative 7 multiplies the negative 6u. Whoops. And then negative 7 finally multiplies the negative 1. All right, let me clean all this up, and then, of course, I'll combine like terms. Well, this is 2u to the 4th. Remember, I'm adding the exponents on the u's. All right, this is going to be 2 times negative 6, which is a negative 12. And then I have u to the 2 times u to the 1. Well, you add the exponents, and that's going to be a u to the 3. Then this is going to be a negative 2u squared. All right, let me keep going. Now I remember this is a u to the 1 here, so this is going to be negative 5u to the 3. Here I have a negative times a negative, which is a positive. So that's going to be plus 30u to the 2. Remember, I'm using the product rule for all of this. Here's another negative times a negative, so that flips to be a positive. All right, let me keep going. I'm going to go to the blue now. And we have a negative 7u squared. I'm just going to copy that down. Then I have a negative 7 times a negative 6. That's a positive 42u. And finally, I have a negative 7 times a negative 1. That's plus 7. All right, it's time to combine like terms. All right, let me start here with 2u to the 4th. I'm noticing there's no other u to the 4ths. So I'm just going to copy that down. All right, now I'm going to go to the u to the 3rds. I'm going to circle this in black. So here's a negative 12u to the 3rd. I'm going to write this off to the side because maybe it'll be easier if I can isolate the u to the 3rds. Then there's a negative 5u to the 3rd. And that's it. There's no other u's to the 3rds. Well, the rule is you keep the variable part the same, u to the 3rd, and I'm going to add the numbers in front. Well, in this case, it's subtracting. Negative 12, subtract 5. Well, that's negative 17. So I have a negative 17u to the 3rd. All right, let me move to the u squared terms. Maybe I'll do this in purple. All right, here's a negative 2u squared. Again, I'm going to write this off to the side, make it a little easier. Then I'm seeing there's a plus 30u to the 2. Then there's a negative 7u to the 2. All right, well, let me combine these together. I keep the variable part the same, and now I'm going to add the numbers in front together. Negative 2 plus 30 is plus 28. Plus 28 minus 7 is plus 21. So I'm going to write down plus 21u squared. All right, I'm almost done. Here's a 5u and a 42u. Well, those combine together to get me 47u. And finally, I'll just bring down this plus 7. I can't combine that with anything else. And here is the final answer. Notice these are all unlike terms, so I can't do anything else to combine this. Folks, this is a messy problem. You have to really, write all this out, get a new piece of paper if you need to. Give yourself a lot of room. And as you're combining like terms, sometimes it's a good idea to circle or check off the terms you've used to stay organized. And if you want to do some scrap work off to the side to help you, you can do that. Whatever method works for you to stay organized as you work out this multiplication and combine like terms. So again, the rule we followed here is anytime you're multiplying a parenthesis like this, where there's additions or subtractions inside the parentheses, you take each term in the first parenthesis and let it multiply each and every term in the second parenthesis, and then in the end, you combine like terms. All right, folks, hope this is helpful as you're working in Objective 13. Let me know if there are any questions.